big shift this week is efficiency turning into a first-class capability. Faster generation, longer context, and better simulation are all being pushed without retraining giant models from scratch. On one side, new decoding and compression methods are cutting latency and prefill cost in ways that actually hold up on H100S and across model families. On the other, robot researchers are turning a single video into a usable digital twin and then multiplying it into training data. The common thread is simple: less brute force, more structure. Keep watching, because the real story is where these systems still break. Let's explore the first paper: JetSpec breaking the scaling ceiling of speculative decoding with parallel tree drafting. JetSpec from UC San Diego, Zhejiang University, UIUC, Nanjing University, and StepFun attacks the speculative decoding scaling ceiling by combining one-pass parallel drafting with branch-wise causal conditioning. Instead of D-Flash-style block diffusion, which can generate mutually inconsistent candidate trees, JetSpec trains a causal parallel draft head on fused hidden states from a frozen target model, so each node is conditioned on its own ancestor path. The paper formalizes the speed-up bottleneck in terms of draft length, acceptance rate, and per-token draft cost. Then shows that a tree causal attention mask aligns draft scores with the target model's autoregressive factorization. Train on 780K examples from NVIDIA's Nemotron post-training dataset V2 plus 20K code alpaca examples. JetSpec is evaluated on Qwen3 8B and Qwen3 30B A3B across GSM 8K, Math 500, AIM25, Human Evil, MBPP, Live Code Bench, and MT Bench. On H100 GPUs, it reaches 9.64 times speedup on Math 500 and 4.58 times on MT Bench, with a 256 token tree budget, outperforming Eagle, 3, D-Flash, and DD-Tree. On Qwen 330B A3B, it still achieves 9.45 times on Math 500. In VLLM serving, a single H100 sees throughput rise from 127.8 TPS to 553.3 TPS at batch size 1 with budget 128, showing the method's practical latency gains under realistic load. Let's explore the second paper: Long Attencomp cross-family context compression for long context reasoning. Long Attencomp from Samba Nova Systems adapts ATN comp into a cross-family long context compressor for 100K plus token reasoning by fine-tuning only a lightweight cross-attention scorer on top of frozen llama 318B instruct, and operating at token chunk level instead of document level. The method adds a token budget top P selector, positional reordering, and a format-agnostic query parser, then trains in 2 stages. Stage 1 on 32,000 Squad and Hotpot QA examples to build general retrieval, and Stage 2 on 20,000 Musique, 2 Wiki multi-hop QA, and replay data to strengthen multi-hop reasoning. On Infinite Bench Code Debug, Stage 1 reaches 75.38% on DeepSeek R10528, surpassing full context 74.37% and beating speculative prefill 62.44%. Stage 2 sub-Q improves to 76.9%. The same compressor transfers without retraining across DeepSeek R10528, DeepSeek V3 1, Minimax M2 5, and GPTOSS120B, with gains of 731 points over speculative prefill. On Longbench V2, Stage 2 with budget-only selection and a 512 token parsed query climbs to 48.9% on DeepSeek V3 1 and 49.7% on DeepSeek R10528, recovering 712 points over Stage 1. The paper's main technical takeaway is that task coverage is driven more by training data composition than by architectural limits, and that inference settings such as chunk size and selection mode must match whether evidence is concentrated or distributed. Let's explore the third paper: SimFoundry modular and automated scene generation for policy learning and evaluation. SimFoundry, from NVIDIA with collaborators at Stanford, Georgia Tech, and UT Austin, is a modular reel-to-sim pipeline that turns a single RGB video into an interactive, sim-ready digital twin and then expands it into affordance-preserving object, scene, and task cousins for robot policy learning and evaluation. The system decomposes reconstruction into extraction, mesh generation, pose alignment, articulation inference, physics annotation, and pi-bullet stabilization, while using foundation models such as Def Anything 3, SAM3, Foundation Pose, Gemini Pro 3, Hunyuan 3, D 2.1, and Trellis 2. Across 12 reconstructed tabletop scenes, it reaches 0-shot F, 1 scores of 0.8, 1 0.92, and improves to 0.93, 0.99 with only 3 minutes of per object tuning. Compared with SAM 3D, it lowers reconstruction error and raises geometric fidelity. For real-to-sim evaluation across 7 manipulation tasks and 5 policy architectures, SimFoundry simulated rankings track real-world success with mean Pearson correlation 0.911 and mean MMRV 0.018, exceeding the Polaris baseline by more than 0.59 Pearson points. For sim-to-real training, object cousins, scene cousins, and task cousins improve average real-world task success by 17%, 21%, and 40% respectively, while multitask cousin data raises generalist policy performance by up to 31% in simulation and 18% in the real world, including 29% success on held-out tasks. The automatic background pipeline also outperforms manual alignment, with PSNR 15.29 versus 12.91 and NCC 0.749 versus 0.549. That's a wrap on today's AI paper highlights. Thanks for watching.